Okay, so the last topic that we're going to review and kind of learn for indefinite integrals is inverse trig. So this is actually a quick topic. It's just really a refresher on those rules that you're supposed to memorize. So I have 3 listed here because the connection to the other 3 are really quick and easy. So the 2 that show up the most are inverse sine and inverse tangent integrals, okay? So keep in mind this would be done with, I call it a mini u substitution because you wouldn't want your entire u to be 1 minus u squared. You just want it to be that function. So remember, a is a constant, so it doesn't have to be a 1. It can be any number here, okay? And so when you integrate it, because of that, you will have to remember when you do the integral that it's u over a inside, okay? So that can be a number. As a quick refresher, if this is negative and all of this is the same, then that's arc cosine. If this is all the same, but it's a negative, then that is 1 over a arc cotangent. And notice on this one, there's a 1 over a in front. You do have to memorize that, okay? So it's not the same process as the derivative, but through a similar process, some of these coefficients are necessary. And same thing here, if you end up with a negative sign, you can also write this as 1 over a arc cosecant. And as a general rule, remember that inverse tangent with the little -1 and arctangent mean the same thing. So be flexible with that. It's not like one's better than the other, okay? So arc sine and sine with a little -1 exponent, they mean the same thing, okay? So even though the AP does sine and tangent, I did include some of the others just as a refresher. In other Calc 2 and Calc 3 and other classes, it's not always going to be just sine and tangent. So by not learning the other 4, it's kind of a disservice. All right, so I called it a mini u substitution just for that portion. All right, so let's look at my first example. So if the dx bothers you on top, remember you can always write that on the side. And then I see a negative here. So all that's going to do is indicate it's one of these pink ones because there's a negative there. Okay. So then I really just want to match them up, and all of the forms are different. One has a radical, one has no radical with a plus in it, and then the last one has the function in front, and there's a number in front as well, okay? So keep that in mind. All really look different. So this one is in the form of arc sine and arc cosine, okay? So what we want to do is we want to figure out what did they pick for A and what did they pick for U. So I think for A, they picked 2 squared, so that's A. And for U, they picked X. So since U equals X, I don't really need a U substitution, okay? If it was more than just X, then you would need a mini U substitution. So since I've matched this up, I don't have to do a mini U substitution, we're just going to memorize that it's inverse cosine U over A plus C. So arc cosine U over A plus C. Now, once again, with the domain restrictions, you might see some absolute value signs. Be flexible. Okay. So arc cosine, I know U is X and A is 2. Okay. Inverse trig does have a domain restriction, so it's still a function. All right, that one's done. On the next one, I don't see a radical at all, so that has to be either arctangent or arccotangent. Since we don't have a negative, it's going to be arctangent. And so the tricky thing about this is you have to remember the 1 over A in front. So we're going to go ahead and I'm going to think of this 2 as being out in front. And so I've got 1 over 4 plus 9x squared dx, okay? That 2 doesn't have any relationship with A or U. So on here, we want to find out what A is. So that's 2 squared, so that means that A is 2. And then 9x squared is really 3x quantity squared, so that's U. So since U is more than just x, I do have to do a mini U substitution. So u equals 3x. So du equals 3 dx, and we don't want that 3. So 1/3 du equals dx. So our a matches. This is now u, and in order to accommodate the dx, we need 1/3 du. So then it's in the form 1 over a squared plus u squared. See, that's why we have to do that many u substitution. So we get the 2/3 stays, and then it's still going to be 1 over a inverse tangent u over a. So 1 over a inverse tangent u over a plus c. Okay? Now, if you can skip steps, that's fine. I just don't like to, especially when I'm trying to teach something. So the 2's reduce. I get 1/3 inverse tangent of 3x over 2. Okay? So as a rule, I typically, all of these do just have those domain restrictions on the u. Last one. So this is kind of a tricky thing. I wouldn't say this is going to be on the AP test, but I'm still teaching Calc 1, so it's always good to learn this. So the technique of completing the square can be useful, because what happens, let's say I didn't. So if we want to integrate this problem, well, I'd have to pick u equals x squared plus 10x plus 29. Du is equal to 2x plus 10, and I don't have any other terms that would give me that 2x plus 10 to match it up. And so what happens is we say, ooh, well, that didn't work, so now what do? I can't split these up because when you have 3 terms being added in the denominator, you're not allowed to. And so you're kind of stuck. So you're like, ooh, what do? And so this is where completing the square comes in handy. I taught it in Sec 2. I don't know if you review it in Sec 3 or not, but I think you do because you learn conics. So I'm going to put a 1 here. And the way it works is we're going to group these 2 terms together. I'm going to leave a space, and then I'm going to put the plus 29. Okay? So completing the square, you take this middle term, you divide it by 2, and you square it. Okay? So we kind of think of these together. So 10 divided by 2 is 5. 5 squared is 25. Okay? So I'm going to put that together. Now, I can't really just add 25. So to balance that off, I'm going to subtract 25, because 25 minus 25, that gives me 0. Okay? So mathematically, I can do that because I really haven't changed the original function. So then if we factor this, you get x plus 5, which is x plus 5 squared. And then 29 minus 25 is positive 4. And so this ends up being 1 over, and then what if I switched places since these are being added, and I wrote it like this? Okay? So all I did was I rewrote the original problem. By completing the square, I haven't changed any values, and now I have it in a different format. Okay? And so you might still be thinking, okay, I still don't see how that helps, Mrs. Eden. But if we go back up here to our inverse trig rules, I don't have a root, but I do have this right here. So see, if we had 1 over a squared plus u squared, that's inverse tangent. And so that's what we have. This is like 2 squared, and this is already in the form of u squared. So I would still have to do a mini u substitution. So du just equals dx. And so I don't have another constant that I have to multiply by. So then since this is in the form of 1 over a squared plus u squared, we're ready to integrate. So we get 1 over a inverse tangent u over a plus c. And so what happens to something that we weren't able to integrate, now we can. Okay? So I wouldn't necessarily test this, but I think still learning all of the different techniques when you integrate and why we learned some of the stuff we did in our other math courses is kind of a good connection and review. Okay, so mainly focus on the first two types. I do have some examples for you to try. Oh, and I have some more. So don't fall in love with inverse trig, because some of these, especially on a section where I talk about inverse trig, it might look like it, but make sure you go through the form and you don't just assume things, okay? So let's look at these three. It looks like it's a squared minus u squared, okay? Except, let's say we picked a big U. So if we do 5 minus 2x squared, du is equal to negative 4x dx, and so negative 1/4 du is equal to x dx. Now the issue is I don't have an x to cover it up. So what does that mean? Well, that means that it's not that kind of a u substitution. But it also, it kind of looks like this one. So we have a root, a squared minus u squared. These aren't really nice numbers. So, but you're in AP Calc, so we can deal with some not nice things. So we have to think, what did they square here? Well, if you're not sure, take the square root. So root 5 squared, that could be 8, because root 5 squared is 5. And then what did they square here? Same thing. I can think of that as root 2x squared, because root 2 squared is 2, and then x squared is that. So this is a mini u substitution because it is inverse trig. So u equals root 2x, du equals root 2 dx, so 1 over root 2. And we don't really need to rationalize in AP Calc, so I wouldn't. Okay, I know some of you still do, and that's fine. But I get 1 over root 2, and then it's 1 over a squared minus u squared. Okay, so then we just have to remember that if we had its arc sine, it's positive, and there's no 1 over a in front. So this isn't the 1 over a. So arc sine u over a plus c. Now, we really can take that root out and write it as like root 2/5. Make sure that x is outside. I would even put it in the bars if you want to. Now, if I was a student, would I want to? No, I don't even want to as a teacher. So I'm okay with that. You should be able to match this up, and it would be a multiple choice question. These are not going to be free response questions on an AP exam. Okay? All right, let's look at the next one. So this one, you might not even fall for it, but I think it's trickier than what it looks like. So we see an x on top and we see an x squared on bottom. So a lot of students will say, oh, okay, so let's do u equals x squared plus 4, du equals 2x dx, and so 1/2 du is equal to x dx. Well, the only issue is I don't have an x dx, I have an x plus 2 dx. And if I manipulate the u like we did before as our trick, that doesn't work either because you can't take the square root of u. Like, you're not allowed to do that at all. You're only allowed to multiply or divide by numbers. So what that means is that that's not u. Okay? And so you think, well, it can't be inverse trig because I have an x on top. And you're right, it's not inverse trig either. So what we need to do is a new trick. Because these are being added, I can't split my denominator up, but I can split up my numerator. Okay? So I can think of this as x over x squared plus 4 dx. And then I can also do the integral, and because I'm adding, of 2 over x squared plus 4. Okay? So we can split up the numerator. You're just not allowed to split up a denominator that's being added. So we can integrate these separately. So this one, I'm going to say, ooh, wait, I actually like that box up there. Let's go back and use that now. Okay, so don't erase stuff because you never know. So if we integrate, I would get, this is u, that u. This is 1/2 du. So we get 1/2 1 over u du. And so remember, that's natural log. Okay, I don't need my plus c because it's at the end. This one, I can pull that 2 out, and then this looks like inverse trig. So it's x squared plus 4, no root. So if you go back up here, just wrote the a first, that's okay. So we've got inverse tangent. So we've got 2 squared, that's a, and x squared, that's u. And since u is just x, we don't need a mini u substitution. If we did, it would have to be a different u. So if you want to use v, you can, but I just make a different box and I keep it all separate. So the 2 is going to come out, and then it's 1 over a arctangent u over a, and then plus c at the very end. So the 2's cancel, and we get plus arctangent x over 2, and then 1 big plus c. This is really long, but that was kind of a tricky one. All right, the last one, probably about as mean as it gets. And not on the AP. This is just to show you another technique that's possible. So you have x cubed, but if you let u be x cubed, then du is 3x squared, but I can't have x squared plus 1, and I also can't have that in the denominator. So the only way it works when your numerator is bigger than your denominator is long division, okay? And so this is totally going to be an Algebra 3 review. So if we have, you put x cubed inside, x squared plus 1 goes on the outside. And then you have to ask yourself, if you have x squared and you want x cubed, what do we multiply by? We multiply by x, and then we actually multiply. X times x cubed, x squared, x times 1. And so then remember, we're supposed to subtract or you change the signs. So those cancel, and then nothing minus x is negative x. And so that's your remainder. So really this problem is x, because it went in once, and then this is my remainder. So we write our remainder over our divisor. Ooh, never thought you'd see that again, did you? Okay. So remember, if we're adding these, we can integrate them separately. So this is going to be a power rule. So I get x squared over 2. And then we want to integrate this. Well, if this is u, let that be my denominator. So du is equal to 2x, and we can divide. So we get minus, well, that's u, 1/2 1 over u du. So x squared over 2 minus 1/2, and then this is natural log. Now, do we need those absolute value bars? No, because x squared plus 1 is always positive. So I'm going to leave them because why not? Okay, so the inverse trig was actually pretty quick, but it's always a good idea to learn some of the other ones that might look like inverse trig, but they're really actually harder techniques. So I have given you 1, 2, 3, 4 problems to try. Okay? All right, good luck.